In this question, we have input n. All right, and again, we have a base case, which is going to exit this function when n is less than 1. And we have this for loop that is run from I equals 0 to n. So this for loop is going to run n times. And each time in this for loop, the only thing it is doing is just print out a statement, yo. And it is just one statement. So the work that is done in each iteration is just 1. And therefore, this whole for loop will give us a n. So let's say a theta n runtime for this for loop. Because there is no best case or worst case. You need to run this for loop no matter how. All right? And the only thing that we need to know is here. So in this case, we are having a recursion call. And this recursion call, what it's doing is it is time n by 0.999. So as you may find. So if we draw this tree again, at first we have an input size of n. And then it became 0.999 n. Right? And then it become 0.999 square n. And then it become 0.999 cube n. All the way until it got to 1, which reached the base case and exit the function. Right? So, and in each of this function call, we are taking a linear runtime with respect to the input. So that being said, the first function call gives you a theta n, and the second one gives you a theta 0.999 n, and the third recursion call gives you a 0.999 square n, and the next one is 0.999 cube n, all the way until theta 1. All right. And in this case, it is really a bad idea to calculate how many layers are there as what we did before, which is because it is really hard and like the algebra is like really complex. And what you do not need that as well. And the reason why is since we know the runtime for each node, we can simply plus all them together to get the total runtime. So plus everything together. Because there's only one node in each layer, and you know the runtime of each node, the total runtime is just gonna be everything plus together. And what is that? So if we take a look at it, we're gonna find out that our total runtime is actually n plus 0.999 n plus 0.999 square n plus 0.999 cube n plus all the way to 1. This is a geometric series. And as we mentioned before, a geometric series like this will give you a runtime of theta n. All right? And you can work this out by searching up online for how to prove a geometric sequence sum, or just take a close look at it and you may be able to figure it out. But anyways, there is a total amount of work that is theta n. So in this case, again, there's no worst case or best case because you need to do this for loop anyhow, and you need to do all this recursion call anyways. So the final answer is theta n.